3.3, number 122. So this is a little more abstract because they give us h of x, some combination of two other functions of which we do not know the rule. We just have a symbol for it. 4 times f of x plus g of x over 7. So we're supposed to find the derivative. Okay? So h prime of x is. So if I apply the derivative to this whole expression here, I'm going to do this in showing all the rules in a more elaborate manner in the last couple of problems. So the derivative will first move through the sum and apply itself to these two pieces separately. So you would have 4f of x derivative plus g of x on 7 derivative according to the sum rule, because that's the most outer operation happening. The derivative will apply itself to the sum of these two expressions firstly. So that gets the distribution, as we've seen from the rules before. So now what happens? Well, I'm going to use the constant multiple rule. This is 4 constant multiple times some variable expression. I don't know what it is, doesn't really matter, but it's 4 constant applied to a functional expression, and the derivative will bypass the 4 and apply itself to this expression, whatever it is. All right? So I'll have 4 f prime of x. Again, even though I don't know what f is to write out what f prime is, but just the symbols is what I would have here. And it turns out the second expression is the same, because this division by 7 is nothing other than really just a 1/7 multiple, right? It's really a constant multiple of this function g here, right? I would never use a quotient rule in an expression like this, just like I did not use a product rule here because this is a constant. I would never use a full-blown quotient rule on this expression whenever it's just a constant in the denominator. I'm going to always view that as just this fraction times whatever the numerator is. So therefore, the derivative will bypass the 1/7 multiple, apply itself directly to the variable part, which is the function g here. And the problem's already over. That's all it really is.